Okay. All right, let's move on. Is everybody able to hear me clearly now? Great, great. All right, extremely sorry for this. I need to find out an alternative. Okay, so this is the core architecture of Spark. Okay, I'll go into details one by one. All right, I'll go into the details one by one, but let's take a quick break. All right, let's take a quick break. Break for 10 minutes. Back by 10:11 p.m. IST. Okay. All right, I'm back. So should we start now? All right, I'm back. Should we start now? Great, great. So let's start. All right. So I'll give you an overview of what is there in Spark. All right. So the core of Spark architecture roams around the idea of something called resilient distributed dataset. The way the way in case of databases you run your queries around a table or around a view. Similarly, you run your logic in case of Spark around a concept called RDD. Whether you are writing the code in R or you are writing a code in Spark or Java or anywhere, the whole idea revolves around the concept of RDD. Because because when the computation in case of distributed happens is and whenever we are dealing with big data, we are always talking about data first, as in instead of saying that let's bring the data and pass it through this program, we say that let's take this program and run against data. See the difference? In one, we take the data near the computing. In other, we bring the data to the code. While the code is generally very small and data is very huge in case of big data, the transport in case we take the code to the data is far smaller as compared to otherwise. Therefore, therefore, the whole story starts with data. The whole story starts with data. And most of these data oriented language, for example, in case of R, in case of R, we have an idea called data frame. So the whole story revolves around data frame. In case of SQL, our all queries are against database table. Similarly, in the tools like Pig, the whole story is about data sets. Okay, so everywhere in these data transformation or in these data oriented language, the prime concern is data. Similarly, when we were running MapReduce, we always say that this is our input data and then this is map and this is reduce. Okay, so RDD is one. So RDD is that representation of data around which everything inside Spark roams. Okay, RDD is a distributed data set on which either we can run actions or transformations. Okay, so what exactly is RDD? RDD is either actual data or a kind of a lazy representation of data saying okay, this is something which refers to some data lying somewhere else. Okay, so RDD is essentially a kind of representation of data divided amongst multiple computers. You see, these are this is an RDD. RDD, the way you can imagine an RDD is a big array of objects. Okay, and this array does not necessarily have to have all the elements of the same data type. This array does not need to have same object at the same data type of all the objects. Now in this RDD, this big array of objects, a big array of numbers, a big array of strings, or big some numbers, some string. So this big array is spread across multiple machines. Multiple machines. Okay, here it's divided onto 4 different machines. All right. So okay, and you load data from HDFS into RDD. Now you can translate this data to another data using transformations, or you could run something called actions. The operations in case of Spark are divided into two big classifications. Some of these operations are called transformations, and some of these are called actions. Actions do things, while transformations are generally like to-do list for Spark, saying translate A into B and B into C and C into D. That kind of thing is transformation. Meaning, say for example, I say load this data from RDD. That's kind of we loaded the data. Now, after you have loaded the data into A is our RDD representation. Now, A can be transformed into something else. Say filter A, where this condition is true. So all the elements of A which are pertaining to that condition will be put into the outcome. Now this is transformation, and this transformation does not immediately happen. It is just something like Spark would say, okay, fine, you told me that this transformation has to be done, I will do it. And when will it do it? The moment you execute an action. Okay? So if you are familiar with pig, the moment you said pig, in case of pig, the moment you said dump, everything else executes, whichever this data set depends upon. In the same way, so the computation in case of Spark happens around RDD. There are two kinds of categories of functions called transformation and action. Transformation are generally and a statement saying I want to transform this data into that and this into this. It does not really do anything. It does when you execute an action. The moment you execute an action saying store this data there or bring me back all of this data. Now at that point of time, all of the dependent RDDs will be executed. RDD is read only. You never manipulate. You can translate one RDD and create another RDD, but you never modify an RDD. All right. So basically, the whole we will go into more and more details about RDD, how exactly it functions, why do we need to know about it, and so on. So you load data from HDFS into RDD, you do all kinds of transformations on RDD, and then you say action and bring data back to where you started from, your local machine, your driver. So all of this code is launched by somebody called Spark Driver application. So Giridhar's question is, what is the difference between dataset versus data frame? Okay, so okay, Girdhar's question is, what is the difference between dataset versus data frame? Here, when we said dataset, we were talking about pig, and when we said data frame, we talked about R. Okay, so the idea I was trying to put in that whether it's R or whether it's pig or whether it's SQL, there was a way of representing data. All right, all right. Or you remember we had something called, if you are from Hadoop background, you would know that it's something called bag. That is the representation of a data set. Make sense to all of you? Or did I confuse it too much? So we will go into more and more details about RDD. We will try to demonstrate to you what does it mean by and all of these things. Okay. Now there is a question from Rohit. Question is, in both HDFS and RDD, we are reading data and writing result back to HDFS. So where no, we are not reading data and writing back for every operation. Okay, and we are not always reading to HDFS, writing to HDFS. So in case of MapReduce, the only way of storage was the in memory. It was the HDFS. Here, it cleverly figures out whether to keep in the disk or keep it in the memory, and it utilizes the memory of your cluster in order to do the operation really fast. Make sense, Rohit? All right. Brilliant questions. Very brilliant questions. Now, moving on. So, do you want to have a demo of Spark now? All right, let me log in into my account. So, those of you who have enrolled with us must have got the access to the Cloud Labs inside the LMS itself. And all right, let's try to do a little hands-on before I keep on shooting in the dark and keep on confusing you. Let's try to do a little hands-on. I will use console, although in our Cloud Labs you can see all the components from here. Okay, all right, here we go. I'm logging in. I have put copy to clipboard so that the password is not visible for the video demo, and that's very useful for the instructor or anybody. Alright, so here is our console. We have brought the console in the browser so that you don't have to install anything on your machine in order to start learning. To start learning, you should not be dependent on whether you have permission to install on your machine or anything. Everything has been done from within browser. So even this interactive console, so we'll use something called PySpark. PySpark is an instance of uh, Spark with a thin wrapper of Python around it. Okay, so you can see that we are using Spark 1.4 version, and here we can say load, and this data is lying in our Hue folder. Let me just log in into Hue, and all right, and here we have this, and let me just copy it. So we have three different systems. One is Ambari, which is the admin interface for Yarn. This is the Hadoop admin interface, whereby we can install things, uninstall things, delete things, and configure systems, while Hue is a way to interact with the system. So you can go to the file system. This is HDFS, you will see. Okay, you will see HDFS. Okay, all right, so this is good for those who are learning with us and who can immediately log in. All right, so here you can see these are the data sets of mine, and we can go into data, and do you see that? And here inside data, let's say, let me open my big txt. This is my big file. All right, this is my big file. Okay, so I'll just copy this, So this is HDFS. So under slash, under data, under MR, under word count. Please note that this folder is read only for you. You can only write in your home folder. Okay. So, so for all, otherwise this data will become fairly useless very quickly if we make it modifiable. All right. Sorry. We say A equals to SC. SC is our gateway to Spark, and we say sc.text file. And this is the way we loaded the data. Now we can say a.take, and we can just check whether. So A here is, when we say A equals to sc.text file, what does it mean? We are telling Spark that please load this file. Load in the sense that map it into an RDD. And this A is basically an RDD. It says it's a map partition RDD. Okay, so A does not consume any memory. A is just symbolic relationships between the actual file and an in-memory representation. Okay, so A consumes very small memory. It does not mean that we loaded everything. The moment we say a.take, then it starts talking to the file system and trying to execute things. And that's why you see all of these steps. Now it has given us what? It has brought us 10 records from the file. Okay, you can see that. U means Unicode, and here also if you open the same file, you'll be able to see the same lines. One line is one element of this array, and A is an RDD. RDD is nothing but a big data set. We created this big data set from plain text file. This is our plain text file. You see that? This is our plain text file. We said load this file into an RDD, and it loaded this file. And out of this, we said, give me only 10 records. Now we can start converting, translating this data into various things. Okay, we can start translating this data into various things. Let's say we want to convert it into two upper. So we write a function in Python saying line dot up. We say return line dot upper. Okay, so you can say du. See, it got converted. So this is a local function we just created in Python. Now we will ask Spark to do some sort of translation. That's where we say a dot map, as in we are telling Spark that, hey, can you run my function called tu on every element of A? And did you notice that it returned immediately? It means it had just made a note of it. It did not actually execute anything. The moment we say take 10, then it will start working. And now you see it has converted all these values into upper. Okay, it has converted all of these values into upper. All right. uh, okay, so how have you enrolled for the class, for this class? If you have enrolled, it would be your login password will be here. After you go into my courses, you will see Big Data with Spark 12 December 8:30 p.m. along with these details. Is there an error do you see here? You will get your own login. Here it will be your own login. Every student gets their own login. All right. All right. So, okay. So, yeah. All right. Now, so that was a very quick demonstration of Spark. Now, using these techniques of a sequence of maps and sequence of various kinds of and transformations and various let's say, okay, let me try to demonstrate you some cool thing. Let me do one thing. Let's find out what is the biggest word in this file. Okay, good. So what we'll do is we'll say a define max word. All right, and we are given line 1 and line 2. All right, what we do is, okay, so instead of that, okay, so what we do is, let me try to do something else. First, break down it into two words. Let me just break down the whole thing into words, and I say line dot split. So anything you give to two words, say Sandeep Giri, it'll be broken down into into an array of words. What? No, it's all small. You can see that it has broken it down. Now A is this, and we are saying A. For this kind of work, when you don't have you have one to many mapping, meaning one line is being converted into many words. There we say flat map. Okay, we say two words, and there we go. So we can test quickly whether something has happened or not. You can see that the word has been broken. Now we can create a function called biggest bigger word. Okay, bigger word. Now what does this bigger word do is, it takes two words in the command line and it returns the word which is bigger if length of word 1 is greater than length of word 2. Okay, return what? Word 1. otherwise otherwise return word 2. Okay, let's test it whether it's working or not. Bigger word is very simple. So whatever word you give here, it should give us, okay, you see that? It returned us Sandeep and in case Giriax. Now on B, we could simply say reduce and say bigger word. Okay? Now you see that a single word, see, this function gave us this as the biggest word. So this is probably the biggest word in this file. Alright? Biggest word as in number of characters without space between them. Do you see that? So we have been able to quickly do the map reduce in fractions of seconds without having to worry about creating jar, uploading jar, and then submitting the job, checking it in the status, and then going back to HDFS and checking that file. That is the difference between MapReduce, between the MapReduce and Spark. All right. Is everybody with me, or have I been a little fast in this? So the overall idea is to give you a quick feel about how does Spark work. Yeah. All right. Good. Now let's move on with other ideas. Or do you want to do a word count now? So Srish's question is, how does it differ from Hadoop streaming? Even Hadoop streaming is done through memory. No, Hadoop streaming is not done through memory. Hadoop streaming is nothing but normal MapReduce, which internally making system call to the binaries which have been provided as the argument. Okay, it's a basically a MapReduce and wrapper around it. Do you remember in case of C program, we had this system command? Or you remember how do we execute a process from within Java? Okay, so that's what the Hadoop streaming does. Hadoop streaming, instead of using your Java logic or Java function, it basically uses external library as your mapper or reducer, existing binary as mapper or reducer. There is no difference in terms of mechanism. It doesn't do that. Just that it sounds like streaming, but it's not streaming. Okay, it sounds streaming. It is called streaming because we are passing the data through a process. That is why it's called streaming. Okay, we are passing the data through a process. That's the way filters of Unix are modeled around. That is the way commands like sed work. And therefore, like sed is stream editor. It does not mean that it handles the video stream or it handles the data in real time. It only means that whatever input data is given to it, it operates on that. All right, so streaming is heavily abused word. YouTube streaming is one such use case. Second is real time streaming, which is related to do the computing on the data that is being received every millisecond or every second. Okay, did I make sense to you now, Shrish? Great, great questions. Great questions. This is a common confusion which I also had before starting to learn Hadoop in 2012. I thought that streaming means the real time one. Okay, kind of a misnomer. Great, great set of questions. And moving on. So that was a quick hands-on where what we did was we used map and reduce. Map basically accepted whatever it is and did the execution only when we said reduce. Reduce is an action while map is a transformation. So that's how whole Spark is modeled around. All right. So most of the bigger algorithms have been broken down into these transformations and actions around which the whole computation revolves. Okay. All right. All right. Now, the Spark SQL. What is Spark SQL? Spark SQL is a wrapper over the Spark core which we just discussed. The part which we just discussed is great for those who are from the development background. But there are a lot of people who are not from development background. There are a lot of people who are from databases background. They would want something in terms of SQL and and would like to churn the data in terms of SQL. So the RDD could be churned using an SQL via Spark SQL. An RDD will behave like a dataset to the Spark SQL. Okay, so that those who are not very programming savvy, the people who are not from development background, they can run and churn data. Also, even if you are from programming background, you will find SQL easier and quicker as compared to do the writing the code. All right. So that's why Spark SQL makes a lot of sense. Using Spark SQL can read data from Hive, can can utilize the Hive UDFs, and can also utilize the same library which have people have written for Hive to load and update the data. Now, Spark SQL can talk to the Hive metastore as well. So those are the brilliant compatibilities that have been done by Spark. Spark made sure that it is compatible with entire Hadoop stack or entire popular stacks so that there is an adaptation. So apart from Spark being faster, they did clever thing in the sense that they stayed at as a computing library while while depending on the existing systems. All right. So using Spark SQL, you can also load data from typical databases and you can do performance and scalability. Also, please note that in the previous screen, when we talked about RDD, you can do intersection between multiple RDDs such as join and left join, right join, and whatnot. So multiple RDDs can be joined together by using the join and where clauses. Okay. All of that is also possible through Spark SQL. Does it mean we can run existing SQLs using Spark SQL? Yes. All right, Arpan. So sounds great to you? All right. Now, when people realize that Spark is doing the computation really fast, when people realize that Spark is doing computation pretty fast, many libraries evolved. Many libraries evolved. Even people who were not very comfortable with Hadoop MapReduce, they started migrating a lot of libraries onto Spark. For example, Mahout is being rewritten on Spark. So a lot of libraries are being written on top of Spark. And one of the first libraries that got written by Spark Streaming. And because people realize that they can do streaming really fast. And what does it mean by Spark Streaming? It's not same as Hadoop Streaming again. So that streaming word is something very abused word. Okay, here Spark Streaming means giving a lot of data in real time. Given a lot of data in real time, you can store, you can process data per second. Okay, so what happens is, let me take a concrete example. Let's say lot of events are happening in your data center. You are an e-commerce company. Lot of events are happening in your data center, that the events like the order got placed, this got placed, that got placed. Now there are many people who are dependent on these events. One is that all these systems who are generating these events, they keep a reference, hard-coded reference of all the people who want to listen to those events, or they can build something called a queue infrastructure, pub sub infrastructure, publisher subscriber infrastructure. So most of the organizations have centralized enterprise buses or the queues in which there are a lot of events put. Okay. The project where I was doing for Amazon, where Amazon was having this brilliant infrastructure where lots of pages were being updated by various sellers. Various sellers were updating their product page. They were changing the titles, they were changing the titles, they were updating images, they were improving the content, and so on. Okay, so there were lots of people updating the catalog. Now all of these updates were being pushed into a queue called SQS. And I was listening, I mean, I wrote a program who could listen to the queue, and then whatever the changes are there for those pages, I was computing the pre-computing the image that has to be displayed on the left top corner on the product detail page. So every time there is a change that happens to the product description of anything, I do the reselection of the image that has to be displayed as the main product image on the product details page. Now, that was stream processing because there were hundreds of updates coming per second. And then for all these hundreds of updates, we had to run systems in parallel so that we should be able to do the computation, even a very big computation to update the image. All right, all right. So you can imagine that a queue like this, all right, users are writing to the queue from all around. Now this data is traveling in this queue, okay, and are listening to many users are listening to this, okay, many users are listening to the data. All right. So on one end, various applications are writing to the same queue. Okay. Many applications are writing to the same queue and many applications are listening from the same queue. All right. Of course, there's a segregation between the data written by various processes. Okay. So the example of real-time processing could be consuming the data from Twitter and displaying the sentiment in real time. Okay, now imagine that if there is so much of data coming from Twitter, how will you update the graph and all right, all right. So we have various kinds of queues such as Kafka, Flume, HDFS, ZeroMQ, Twitter, and many more. So these are the kind of continuous flow of data that you can receive. And Spark Streaming, you know what does it do? It reads batches of data from these queues. Okay, it reads batches of data from these queues. For example, it will pick up these many records, okay, and create an RDD out of it. Okay, and on that RDD, you can run your remaining operations as if it's an RDD. That's all it does. It's a thin wrapper around Spark. So what does this thin wrapper do? It reads data in batches. Say you configure it to read every second. So it will read every second's data and create a big array and we call it an RDD. and then it will run all the operations which we have scheduled to run, and then generate the result and save it somewhere. And again, after 1 second, it will read another batch, and then again all those operations which you have already defined, it will run those operations and save the results, and it will keep on doing continuously. There is no end to Spark streaming. All right. Is that clear to everyone? Was I able to explain what does it mean by Spark streaming? Feel free to ask again. I'm okay completely. So maybe this person is trying to plot some graph. This person is trying to do the prediction in terms of this person will like this and so on. And this person is doing a fraud detection. Okay. This is okay, this is not okay, that kind of thing it is doing. So there are many applications who are observing the data, they are taking various calls. All right, I will answer your question, Srish. Question, okay. Just give me a second. Let me answer the questions related to the Spark streaming. Okay. Now, Arpan's question is, what is the comparison? What is the comparison between Spark streaming and storm processing? Storm processing and Spark streaming objectives are same. Just that Storm is Storm is little more faster than Spark streaming, because Storm was designed bottom up for streaming purposes, while Spark streaming has been a discovered use case. Discovered use case as in people realize that streaming is doing, Spark is doing really fast things, so why can't we use it for streaming purposes as well? And that's how Spark streaming came into picture. And so the other thing is the storm processing is storm for storm you have to set up your own cluster, while for Spark you can continue to use your yarn cluster. So that is the difference between Spark streaming and storm processing. Okay, the objective is same. All right, the next library which is very popular and powerful is, okay, let me answer one more question. I think I missed the question. Any standard rules, okay, we can define on RDD, example parent and child. So that's something which Spark takes care of it internally. We just generate one RDD from another, or we call an action on an RDD to convert an RDD into the real data. Okay. So there is no such thing called foreign key, public key. No, there is no relations. But you can join the two tables. You can, and it is not a storage per se. It is just for some time. An RDD can be persisted for some time in the memory or saved onto the disk. All right. So I know that I am being really, really rash when I'm discussing these things because I have not planned for it. Okay, so I'm being little more brief as compared to the standard comparison. All right, so Storm has been well proven over Spark, as well as Storm is Storm is takes care of Storm has got lesser latency as compared to Spark, meaning Storm is faster than the Spark stream. Okay. Alright, next is MLlib. MLlib is a machine learning library from Spark people. What is machine learning? Programming computers to automatically optimize performance using past experience. Given the past data, doing the predictions is mainly what lies under the MLlib umbrella or machine learning umbrella. It's a branch of artificial intelligence. It is the it is for the purpose of design and development of algorithm. Rather than people writing algorithms, it infers or it prepares the graph of the data so that it can do the predictions. Okay, it just like we draw a chart or a graph on the historic data, it also does the same thing. So computers evolve their behavior based on empirical data. All right, so that's what is machine learning. Now MLlib, there are many applications of machine learning algorithms, okay, such as recommend friends, state, whatnot. So most of the complex algorithms have been moved to machine learning. For example, handwriting recognition is a complex scenario. The visual detection or say image recognition, those are complex things and very difficult to write algorithms and continuously changing. Therefore, most of those algorithms have been augmented by machine learning. Now, why we are worried when we talk about big data? Why do we worry about machine learning? Why do we talk about machine learning whenever we talk about big data? The answer is very simple. Answer is answer is that machine learning only makes sense when you have huge data. If you have few records and you want to empirically draw a graph, it will be really bad. If you have a single point and you try to draw a graph, it'll be totally insane. It did not make sense. And if you have only 2 points and try to draw a graph, it'll be a straight line. If you have 3 points, then if you want to draw a graph, then it'll make more sense, and so on. If you have billions of records, and only then machine learning will give you brilliant results. If you have say 100 200 results and you want machine learning to do the prediction for you, it wouldn't make any sense. Computer will make lots and lots of error. So the more the data, the better is machine learning. Okay, more the data, better and more accurate is the learning. So that's the whole game about MLlib and the big data. All right, and this is one use case where a big data problem becomes an asset. All right. So MLlib is very easy to use, usable from Java, Scala, and Python. It's very highly performant, and it has got high quality algorithms and provides you the APIs for ML pipeline. There is something called MLlib also provides something called machine learning pipelines. It's a kind of meta language for data scientists so that they can create the pipelines using the MLlib. Now, based on this similar kind of idea, Google has also released something called TensorFlow, okay, with which you could build the ML pipelines. Now, in case of MLA, why do we need to worry about? I mean, why MLlib is better than any other machine learning library? Reason is that most of the machine learning libraries, such as R, such as NumPy, SciPy, Scikit-learn, most of these libraries suffer from the situation that they only run on a single computer. Okay, so if the memory overflows or CPU is not sufficient, then R or NumPy, SciPy or Scikit-learn, they will fail badly. Okay, so that's where MLlib comes into play. MLlib divides the data onto an RDD and converts all these machine learning complex algorithms into transformations and actions and run that on the large cluster. Okay, MLlib is covered in the course, as in we go through the algorithms provided by MLlib and we experiment with that. All right, next is GraphX. GraphX has got flexibility. Okay, it seamlessly work with both graphs and collections. Okay, let me before we jump into GraphX, let's talk about the most important problem that because of which Google is Google as of today. What was that algorithm? Who can tell me the name of that algorithm because of which Google is Google as of today? Because of which Google became successful as compared to all other search engine. Anyone? Correct. That's correct, Nadeem. That is PageRank. Yes. It is PageRank. So what is PageRank? One page is linking to another page, meaning it's giving more priority to the another page. And based on that kind of voting, Google started computing the PageRank. Okay, and PageRank was one such algorithm that needed to be run on hundreds of computers parallelly. And basically, if you imagine the whole World Wide Web, the pages are interlinked. Okay, if my website is linking to your website, that means your website is more important. And further, if your website is linking to somebody else, then that website is far more important, because I gave a vote to you, your priority improved, and your website, whose priority is more important than me, voted for somebody else, then that person's website is far more important than mine. That's how the page rank is computed. Now, if you think about it, there'll be loops, there'll be cycles, and so on. To do the computation again and again is a very complex task. So, PageRank was basically the first implication of Google MapReduce, where they tried to convert the PageRank algorithm into MapReduce. So, those kind of algorithms where there are many complex things that happen in the world of graphs, there are many complex things that happen, and those complexities are absorbed by this library called GraphX. GraphX provides you a list of functions with which you can churn big graphs. So you can represent graph using graph, the data structure provided by GraphX. Also, it provides you the basic constructs of representing various elements in a graph. Like, what is a graph? Graph has got nodes and graph has got connectors. So these nodes are connected to other graphs. Most of the problems in real life are expressed and can be expressed very well using a graph. There are many algorithms on top of graph which GraphX provides. Okay, so that is something which Spark did really nice. So in GraphX, you seamlessly work with both graphs and collections. Its comparison, this GraphX is performance is fairly fast. You can choose from a growing list of graph algorithms, and there is a great community around everyone. These are the common algorithms which are used out of the GraphX library. First one is PageRank. Second one is connected components. Connected components are those components which are connected together. Okay, so figuring out connected components is probably very important. Not probably, it's a very important phenomena in the computational world. Okay, next is the label propagation, then is svd plus, and strongly connected components and triangle count. Triangle counting is another complex scenario which is very much used in animations. In animations, you basically do the counting of the triangles and try to guess how many surfaces are there. All right, so next important component of Spark is R on Spark. It provides a data frame like usual R's data frame, and that data frame under the hood is nothing but a an RDD. RDD means Resilience Distributed Dataset. It lets you import data from R. You have rich operations from R, which are group by, filter by, etc. The biggest and important criteria and the reason why Spark R came into play in the first point, the reason was the memory limitation of R. If you try to do even the simple thing, there are high chances that you will overflow the memory. Okay? Run SQL queries on R data frame. Okay? Meaning, it not only provides you a data frame inside R, it also let you manipulate the same data frame using SQL and same data frame using R. Okay? Also, the very important aspect is Spark R allows you to use existing R packages. It allows you to use. This is probably one of the very big thing that happened. First, it started allowing people to use the existing, because R has got tremendous amount of library. If you have a look at the R's library, you will be surprised that they even have a library for social sciences. I mean, can you imagine programming library for social sciences? So that kind of library R has. All right. So okay. So that was pretty much about from my side. If you have any questions, I would like to answer them now. Okay. And we can do a little more hands-on on Spark. Do you want to do a quick word count on Spark? All right. All right. So let's try to do it. Let's say we load the data in the same manner. SC is the Spark context object, which is additionally provided to you on this Python interpreter. Okay. So here we say, please load my file called slash data slash mr slash input slash big.txt. Okay, so we say that, okay, please load my file called this file into A. This is my file. This is my file. I'm trying to load it into A. Now let's break it down. Break A, or let me say input. Okay, so let me just say input. Okay, that is our input data. Okay, is everybody with me? Yeah, I think I have put all of you to sleep. Looks like, yeah. All right. All right. So let me just try to do, let's break it down into one word. So by default, what would happen is in will be an RDD that contains lines, meaning it's a big array of lines. All right. Now let's break it down to words. And to break it down to words, what we need to do is we have to define a function called toWords, which takes a line as argument, and then it returns it returns, okay, line, not like this, we'll have to say line dot split. Okay, or if you want to remove or replace some word, you can replace it here. All right. Now, since two words is going to break each of the RDD element into multiple elements, we need to run it like using the flat map. Flat map to word. Okay. So once we have broken down into the words, this is done into word. Let me just write words. Now those are this is an RDD, and when you translate an RDD using a transformation, this is also an RDD. It's a resilience distributed data set, which is broken down into so this is the input words which we are loading. Okay, sorry. So we have translated in two words. Now next step is let's try to remove. Do you want to remove some words? No. Okay, let's try to convert key value. Okay, let's try to convert each word into a key value. So we say return word comma 1. That's it. So it'll create a kind of a object which has got key value. So we say kv words. These are the names we are giving at our win. We are giving it to it. Now we use map means run our function on every element of this. Okay, so we have, all right, good. All right, I think a better thing would be to do it real time, as in from here itself. That's the biggest benefit of having the console. Okay, let's just test it as we are going ahead. Alright, let's see if it converts into an array. Yes, it has done. It has splitted it. Now we can do, okay, now we got words. Next is, let's try to convert things into tuple. So we are saying 2kb and let's see what happens. Good, it has converted into key value. Alright, now kv words, let's see what is there inside kv words. It says input path does not exist. Why it doesn't exist? Why it doesn't exist? Says data mr input. Oh, I had to say word count. Alright, I had to say word count. Yeah. Word count. Alright, now it'll be okay. That is why an interactive way of working is better, because such kind of errors can be quickly tested. Here you could say take 10. Alright, take 10. Alright. Now what happened just now is one of the machine refused to work, so it reloaded the data from any other machine. Okay. Alright. Now KV words is working fine. Now what we can do is we can define another function which will reduce by key. So what we'll do is we'll just define our function called sum, which will basically sum up two values together. Okay, return v1 plus v2. Now you will notice that this sum function sm function, although it sums up only two values, okay, like here you can see it sum up two values, but when we run it against here reduce by key, okay, this is word count. Okay, when we run it here, what will it do is this function will be applied again and again on all the values for each key until there is a single value. That's how the reduce work. Okay, so wc dot take time. All right. Also, we could say wc dot save, and in case you are not aware about this, you could do things like this. You could do dir and it'll give you all the available functions on a file, on an RDD. So it is going to store the data in HDFS in a folder called SSS. Now let's have a look at what is there inside that SSS. Alright, you see that it has done word count in two parts. Okay, you will see that it has done the word count. Alright, alright, so this is how the most of the magic of Spark works. Okay, this is how the magic of Spark works. Alright, in case of Python, you can simply say dir or help to find out about anything on an object. Alright, so Valentin's question is, alright, let me just copy paste so that everybody can see it. Okay, so his error is this. Actually, this F has to be capital. Okay, you have to say this as capital F. Alright. Alright, there is a very good question from Rajesh. Question is, do we need to write custom input format like MR? Actually, the beauty of the Spark is that they have made it possible to use the same input format as was there in Hadoop in here as well. So did you notice something called help and SC? Okay, when you say help on SC, it'll show you all kinds of functions, out of which one of the functions which I wanted to show you is something like this. Okay, there is a Hadoop RDD, okay, or Hadoop file. Okay, using these methods you can use the existing input format which have been defined for for Hadoop. You can use the same input format here. Okay, sounds good. Valentin, are you able to do it now? All right, so that was Rajesh's question. Okay, how does Spark read files from custom HDFS? All right, great. Rajesh, was I able to answer your question? Yeah? No? So you generally can utilize whatever input format that have been written in Hadoop here in case of Spark. In case you have custom file format, you can write the loaders, custom loaders. Okay, that's not a big deal. All right. Any other questions for me? We still have 6-7 minutes. Yeah. In case there is a custom format that is not yet supported by Hadoop, what you can do is you can create your own input format and use the same. There are ways to Spark provides you a custom mechanism to read the data. All right. Also, most of the translations happen after you load the data. So the RC file, if you remember, RC file, zipped file, and compressed file, all of that data can be very well read in Spark. Okay, we'll go into more and more details on how can you churn CSV, how can you churn tab separate file, how can you churn various kinds of data using Spark itself. Okay, any questions for me at this point of time? So house question is any lab to test the, so actually here our lab is not a single machine. Okay, our lab is actually bunch of machines. I'll show you this. Right now there are 6 hosts. Okay, right now there are 6 hosts here. Okay, and these 6 hosts are running Spark as well. Okay, so basically these are multiple nodes which basically give you the real experience of a cluster. All right. So I wanted to, so this is our Ambari. Using Ambari, you can create your own hosts. You can create your own systems. It's not a big deal. You can set up your own cluster, but just that it takes a lot of time to sometimes manage it and take care of the cluster. All right. Any other questions to me? All right. So information to all of the candidates. The All right. So great. I'm happy that Valentin is able to use the map, this thing, MapReduce. Now, good question. Good question. Why does it split the result? That is his question. So we missed that point here while I was explaining to you. There were two parts to it. Okay, that essentially means the RDD had two partitions. The RDD which we try to save here, this WC, had two partitions. Internally, it created two partitions based on certain criteria. All right, that's all. The if it has hundreds of partitions, then you'll get hundreds of files. So Rahul is saying, is yarn cluster necessary for maintaining a Spark cluster? So if you have any other cluster manager such as Mesos or Apache, Amazon EC2, it's completely okay with that. But if you have Yarn, then use Yarn for Spark, running Spark. Okay? Or in case you don't have Yarn, still you can just download Spark and start working with that. It'll run in a standalone mode and it'll run happily. Alright? Great. Great set of questions and brilliant questions. So that is pretty much from my side. If you have any questions, uh, feel free to let me know. There will be no class tomorrow. All right, to all the candidates, there will be no class tomorrow. The next class will be on the next weekend. All right, next class will be on the next weekend. All right, so there was somebody who was saying that he will not be able to attend the class tomorrow. Nothing to worry. Okay, there will be no class tomorrow. The next class will be on next weekend. All right. Thank you very much. It was a great session in the sense that I got great questions from you, and I look forward to the rest of the classes. All right. Thank you, Vijay. So you can reach out to me on this on reach us at no big data. Okay. On reach us at no big data. All right. All right. Thank you, How. Have a good weekend, you too. Thank you, Nadeem. All right. Thank you, Sachin. I'm happy that you found it really great. And thank you, Rodney. I hope this session added some value to you. All right. Okay. All right. So Vijay says that it's a good kickstart for beginning. Yes, it should be. All right. Thank you, Shreyas. Thank you, Rajesh. All right. All right. See you next week and have a great weekend ahead. All right. Bye bye. Thank you very much. All right. Thank you, Valentine. And send me the video recording after the session.